Proper boiler operation requires the flow of feed water into the boiler to equal the flow of steam leaving the boiler. If too much feed water flows into the boiler, moisture could eventually build up and carry over into the main steam system. On the other hand, if there's not enough feed water flow to meet the demands of the boiler could boil dry. Feed water flow can be controlled in various ways. A feed water regulating valve may be used, or, as in this system, feed water flow can be controlled simply by varying the speed of the boiler feed water pumps. Other systems control feed water flow by using a combination of varying the speed of the boiler feed water pumps and changing the position of a feed water regulating valve. Two additional systems are normally associated with a condensate and feed water system. They are a chemical addition system and a make-up water system. The chemical addition system may be connected to the condensate system, the feed water system, or both. It generally includes pumps and associated equipment for adding chemicals such as hydrazine to prevent corrosion and ammonia to control pH. The make-up water system is connected to the main condenser's hot well. This system adds pure water to the condensate system to compensate for water losses that may occur due to condensate sampling or to steam or water leaks in the system. The make-up water is stored in a condensate storage tank. Make-up water system designs vary, but most also include purifying equipment, such as evaporators and demineralizers. If you're responsible for keeping a condensate and feed water system running smoothly, you must be thoroughly familiar with normal operating conditions for the system so you can distinguish between usual and unusual conditions. Making regular checks of levels, temperatures, pressures, flows, and valve positions throughout the system as it operates helps you detect problems early so that major trouble and costly downtime can be prevented. Specific concerns associated with the operation of your facility's condensate and feed water system are usually covered in your plant's standard operating procedures and in the operating manuals for the individual pieces of equipment. In this part, however, we'll look at some basic operating checks that are common for most condensate and feed water systems. A typical condensate and feed water system includes several multi-stage centrifugal pumps. Checking the pressures, temperatures, and lubrication for the pumps during normal operation of the system is a routine operator responsibility. Checking pump suction and discharge pressures periodically helps ensure that each pump is operating correctly and that proper flow through the system is maintained. Proper bearing lubrication is critical to keep the pumps in a condensate and feed water system in good working order. To make sure that a pump's bearings are being properly lubricated, you should check for overheating, excessive vibration, contaminated lubricant, and low lubricant level. One way to check for overheating or excessive vibration is by touching the bearing housing. You can also use an instrument called a pyrometer to measure the temperature at the bearing housing, and a vibration meter to measure the amount of vibration. To check the flow, level, and condition of the lubricant, sight glasses are commonly used. If lubricating oil in a sight glass has an unusual color, this could be a sign that the oil has been contaminated and should be replaced. For this pump, a gauge measures the temperature of the lubricating oil leaving the pump's bearings. If the reading isn't within the normal temperature range, there's generally a problem that should be reported. Many pumps use cooling water to cool the pump's bearings. When you check these pumps, make sure that the valves in the cooling water lines are open. A centrifugal pump often uses seal water to help keep fluid from leaking out of the pump. During normal operation, you should check the seal water to be sure it's working properly. Also, if funnel drains are used for seal water leak-off, check the drains for proper seal water flow. If the flow is greater than normal, this could indicate a leaking seal. If a pump has a minimum flow requirement, a flow rate less than the minimum causes higher turbulence and greater friction, which generates heat in the pump. So recirculation lines and valves are used to maintain minimum flow and prevent overheating. If flow through the pump goes below the minimum flow requirement, the valves in the recirculation line are opened to maintain minimum flow. But when flow through the pump is above the minimum level, the valves in the recirculation line should be closed. Condensate pumps usually have suction and discharge vent lines that are connected to the main condenser. In most cases, the valve in the discharge vent line is closed after the condensate pump has been started and is operating normally. A low hot well level occurs when the amount of condensate leaving the main condenser is greater than the amount of steam that's condensing. This condition could cause the condensate pumps to lose their prime. A high hot well level occurs when the amount of steam condensed in the main condenser is greater than the amount of condensate removed by the condensate pumps. This condition could flood the lower sections of the tubes in the main condenser and reduce the condenser's overall condensing ability. In an extreme case, water from the main condenser could get up into the turbine and destroy its moving blades. A level control loop is used to maintain the correct level of condensate in the hot well. Basically, condensate flow out of the hot well is decreased if the level falls below a preset minimum, and increased if the level exceeds a preset maximum.